Hello everyone, Mr. Schultz here. Make sure that you put the 7-5 in the top left-hand corner, and in the top right-hand corner, put your last name, first name, integrated 2, period 5, and the date. Our title for today is Probability and the Multiplication Rule. So we've been talking about probability of like one event happening. Well, what if we have more than one event? This is what we call a compound event. A compound event is when you roll the die once. What's the probability of getting a 4? And then you roll it again. What's the probability of getting another 4? That'd be 2 or more events right there. So that is a compound event. Next up, independent events are events that are not affected by the outcomes of other events. So some examples of independent events would be, roll a dice. Twice. You could also do a coin toss and a spinner. So if you flip a coin, comes up heads, comes up tails, doesn't matter. It doesn't affect the outcome of the spinner. If you spin, it could get a 1, 2, or 3. It doesn't affect. If you roll the dice, it doesn't affect the other outcomes. This is what we call independent events. So some sample spaces of this, meaning what are all the possible outcomes, would be head 1, head tails, head 3. So for example, we're going to be talking about a coin toss and the spinner. So if we're doing a coin toss and a spinner, heads 1, heads 2, heads 3, and then we have tails 1, tails 2, and tails 3. So the probability of heads and 2 would be, let's think. So the probability of heads would be 1/2. The outcome that we want, the preferred outcome, is heads. There's one of them. And how many outcomes are there? 2. So it'd be 1/2. Now the preferred outcome of 2, spinning and getting a 2, would be 1 out of a total of 3. Now, what we're going to do is we're going to figure out what is that. So in order for heads and tails, basically, one of the rules is we're going to multiply 1/2 times 1/3. And so when we're multiplying fractions, we understand that we multiply across. So 1 times 1 is, and 2 times 3 is 6. So, example 1. The probability of independent events. So Anna is a member of a gaming website that randomly pairs users together to solve puzzles. Of the 50 other players currently online, Anna is friends with 10 of them. Suppose Anna is paired with a player for a game. Not liking the outcome, she disconnects and is paired with another player. What is the probability that neither player that Anna is paired with is a friend of hers? So when she connects, she has 10. So it's asking, neither is a friend. So how much is not friends? Well, that would be 40. The probability that she gets a randomly chosen one would be 40/50. Well, what's the outcome that it happens again? Well, she just disconnected from somebody else who's probably going to re-up again. And so the probability would be 40/50 again. And so what we're going to see is we're going to multiply this and we're going to see something. What we're going to see is we can cancel this out. This would be 4/5 times 4/5 to divide by 10 on the top and the bottom. And that would give us 16/25. That is the probability. 16/25 would be the probability of, P not friend twice. So it's P not friend times P not friend. Oop, I spelled friend wrong. It's a V. It's a F instead of a V. So that's equal to 16/25. What percent is that? Well, if I times 4 and times 4, it'd be a 64%. Now, a lot of this time, you're going to want to change it into percent so that we have that understanding. It's a lot better to understand 64 out of 100 than 16 out of 25. All right, let's make a stop for right now. All right, so it asks us, what assumption do we have to make in order to solve this problem? Well, we would have to assume that the same 50 players stay on for both, I guess, random selections. Because if it changes, then we didn't really do it. The probability changes as well. All right, so let's go on. So we're going to learn about probability of dependent events. So a dependent is someone in the tax code, is someone who depends on somebody else to provide for them. So my children depend on me to get them food. So what is a dependent event? It's when the outcome of one event affects the outcome of the other events. So say we have a bag of marbles. Those are like little glass spheres for games before the Switch or the PSP was invented. The sample space for drawing the two marbles would be red, blue, red, blue, red, or blue, blue. The probability of choosing a red marble would be, well, let's count. 1, 2, 3, 4, 5. There's a total of 5 favorable outcomes. So P red would equal 5 over a total of 7. Once the marble is taken out of the bag, the probability of choosing a red has changed. If a red marble is chosen, the favorable outcome has decreased by 1. The total outcomes is decreased by 1. So the total marbles is now 6. Now, if we draw a second red, that means 1 was already chosen. That would be 4 out of 6. Now, if we draw a blue after a red, now that would be 2 out of 6. Because the blue marble hasn't changed. It's still 2, but now it's out of 6 because one of the marbles has been taken out. Now the probability has changed. It's not out of 7 anymore. It's now out of 6. So now let's decide whether certain events are going to be independent or dependent. Does it change? Did we take anything away? If we take something away, that is dependent. Just think of like your parents are like, give me your Game Boy, if this was like 20 years ago, or give me your cell phone, if it's like last week. So one spinner is spun twice. Well, this is going to be independent or dependent. This is a dependent event because the spinner does not change after spinning. That's it. In a raffle, one ticket is drawn for the first place prize, and then another ticket is drawn for the second place prize. Well, what's going on? Well, what has decreased? The total number. So if you had 100 tickets and you took one out, now it's 99. So if something has changed, this is, go back up. This is independent. Independent. If something has changed, it's going to be dependent because the number of events have decreased. All right, final one. A random number generator generates 2 numbers. Now, in a random number generator, it's going to choose like a number between like 1 and 10. It doesn't matter what happened before. it's going to choose a new number. It could be the same number. This is an independent event because it is fresh every time. It's like it refreshes itself every single time. All right, let's go on. We're on the final one, example 3. The probability of dependent events. So the pizza that Jose and Tessa are eating has 10 slices, is half cheese, half mushroom. Tessa spins the pizza around and randomly selects a slice of mushroom pizza. If Jose spins the pizza and selects a slice after that, what is the probability that both he and Tessa select a slice of mushroom pizza? Well, the probability of mushroom pizza at the very beginning is going to be 5/10. So probability of mushroom is now 5/10. Now, a mushroom was taken, but also the total has decreased by 1. So the probability of the mushroom after a mushroom has been taken is now 4/9. So now we're still going to have to multiply these out to figure out what is our result. So the probability of mushroom and mushroom happening would be 5/10 times 4/9. Now I am going to do a little bit, divide by 2 on the top and the bottom, and I get 2 and 5, and then I can cancel that out, 2/9. So the probability of mushroom and then another mushroom would be 2/9. Now I'm going to pause it right now. All right, so when I actually use my calculator, 2 divided by 9 would be 22.2%. I do believe. So straight up, I'm telling you right now, there's a 22% chance that Jose and Tessa would both eat a mushroom slice of pizza. All right, guys. Thank you very much. I'll see you in class. Bye.